Alright, hopefully you've seen my other video, my first one about what you need to know for equations of straight lines and graphs and stuff, okay? What we're going to do is look through some questions, okay? So here's a very typical one, okay? Find the equation of a straight line that passes through 2 points, right? Even year 8, you need to be able to do this sort of thing. But what we're not going to do is we're not going to use the equation y equals mx plus c, okay? So find the equation of a straight line passing through these. I've not put the straight line, but it should be obvious, okay, that it's going to be straight. So the first thing we're going to do is find the gradient between the 2 points, okay? So I'm going to do 7 subtract negative 1, so 7 subtract negative 1 over 5 subtract 3, okay? Do remember to do y coordinates over x coordinates, okay? This is A-level maths now, it's a mistake you cannot afford to make at this level, okay? So 7 plus 1, that's 8, and 5 subtract 3, that's 2, so gradient is 4, okay? So we've got that. Next, we're going to use this equation, y minus y1 equals mx minus x1. Why have we used that equation? Well, the first and most important reason is because in my previous video I said we're going to use it. Okay, we're not use y equals mx plus c. But suppose, if I'm being honest, the most important reason is the second one because it's actually easier. Okay, and the reason I said so is not really good enough in the grand scheme of things. Okay, so what we're going to do with this? How does this work? Well, the y and x stand for the variables in the general equation we're going to get, the y and the x in the equation of straight line we're going to get, but the x1 and y1, that stands for a coordinate point that we know lies on the line. And we've got two of them. We've got that one there and that one there, okay? So using this one, all right, purely because it's the first one, that's all, no particular reason. Using coordinate 5, 7, I'm going to substitute it in. So the thing to do is replace y1 with the y coordinate, 7, m with the gradient we know, which is 4, and x1 with the x coordinate, which is 5, okay? And we've done it. That's it, okay? We have done it. Can you see how quick and simple that was, okay? This is an equation of the line that passes through these points here. It might not be simplified, it might not be in the form that you want it, but it is the equation of the line, okay? And that's why this here is the preferred equation of a straight line. It gives us an answer straight away. We don't need to faff around trying to find the y-intercept, okay? We can just put the numbers straight away into that, substitute, okay? Plug, if you're an American. Substitute numbers straight away and we get our equation. What I'm just going to do is tidy it up a little bit by expanding the brackets on the right hand side. So it's going to be 4x subtract 20, okay? And look, I'm going to put the negative 7 to that side, so write y equals 4x subtract 13. If you like, that is in the form y equals mx plus c. Now, if you don't believe me, work through the whole question again, using y equals mx plus c, do the bit where you have to find the y-intercept, and guaranteed you'll end up with that the same. Okay? Coming up, this is a second example. Okay, let's do another one of these. Okay, so find the equation of a line that passes through this point and this point. What's different about this question is that we've got a particular form which to leave our answer. Okay, so it's quite common in an A-level exam. Okay, often they ask to leave it in the form ax plus by plus c equals 0. And what I've not put on the end here, because I just wanted to specify this, okay, is to write down that a, b, and c are integers. Okay, that's how it's sometimes written, sometimes in words, but I'll just put the set notation in that, okay? So A, B and C are all integers, okay? So let's have a look through this one. So M, again, we need to calculate that. These coordinates, they're all negative values, all right? But it doesn't really matter which way around you do it. I traditionally just do that pair, subtract that pair, okay? So negative 1 subtract negative 9, so negative 1 subtract negative 9, all over negative 4 subtract negative 3, negative 4 subtract negative 3, and that's going to give me negative 1 plus 9, so that's 8 over negative 4 plus 3, so that's negative 1, okay, so that's negative 8, isn't it? So that's the gradient, m equals negative 8. Then we use the equation y minus y1 equals mx minus x1, so I'm going to do it here, okay, because I've kind of use up a lot of space there, didn't I? All right. So a reminder of the equation, y minus y1 equals mx minus x1. So y subtract y coordinate, so that's the y coordinate I'm going to use. Okay. So y subtract negative 1, that's the same as y plus 1. Okay, and then the gradient m, which is negative 8, and then x subtract the x coordinate negative 4, so subtract negative 4, that's plus 4. So you can see how this equation works when you've got negative values. Okay, it's still just as easy, just got to remember to do y plus 1 and x plus 4. So that would be fine if it wasn't for this bit here. Okay, that would actually give you full marks if it just asks you for the equation of a straight line, because we're done. Get it in this form, okay? So the thing to do is first we'll expand the brackets, because there's no brackets in there, you'll notice. So negative 8x subtract 32 there. And then rather than write it in the form y equals mx plus c, so rather than write it as y equals negative 8x subtract 33, we just need to write it in this form here. So that means put all the x, y's and constants onto the left hand side. So we'll put that onto this side, so that's going to be 8x plus y, and put this into this side as well, plus 33 equals 0. And that's it, we're done. Okay, next example coming up. So here's my third example then. Find the equation of a line that's parallel to this one. So that's 2y minus x minus 6 equals 0. That passes through 4, 5. So find the equation of the line that's parallel to this, that passes through the point 4, 5. And then here it says give your answer in the form ax plus by equals c, where a, b and c are integers. Okay. So the first thing we want to do is work out the gradient of the line. Notice there's a theme here. Pretty much every question that you'll do involving straight lines starts with finding out a gradient to it. Okay. So we'll work out the gradient of this. So what I'm going to do is I'm going to write down the equation again, 2y minus x minus 6 equals 0. And what I want to do is make it into the form y equals mx plus c. Why do I want to do that? Because then that will tell me what the gradient is. So I'm going to put the terms here onto the right hand side. So 2y equals x plus 6, and then divide everything by 2. So y equals a half x plus 3. So that means that the gradient is going to be 1/2. Okay, and then because the line is parallel, that means that the gradient of the line I want to find is also 1/2. Okay. So what I want to do then is find an equation that's got that gradient that passes through 4, 5. Okay. So y minus y1 equals mx minus x1. I'm hoping you're starting to memorise that equation now because I'm using it every single time. The y coordinate we've got is 5, so y minus 5 equals gradient, which is a half. Okay, and then the x coordinate we've got is 4. Alright, so y minus 5 equals a half x minus 4. That's it. Let's see what to do next. We've got to leave it in this form, which means a, b and c are integers. Now this time, rather than expand the brackets, because this is a fraction, I'm going to multiply both sides by 2. Because what that will mean is I'll have an equation that's not got a fraction anymore. So if I multiply both sides by 2, on the left I'll have 2y minus 10, and on the right I'll just have x minus 4. Can you see that quick, simple step? It's probably saved me a bit of time. Okay. Otherwise, you'd expand the brackets, and then you put all the x's and y's into one side, and then you'll end up with the x term, the coefficient of x, not being an integer. You have to multiply it by 2. Just doing it from that stage just saves a bit of time. Now, just to leave it in that form, that means the x and y term have to be on the left and the constant on the right hand side. So I'm going to put that x term onto that side there. So that's going to be negative x plus 2y. Now I'm going to put that onto that side. So that's going to be negative 4 plus 10. Negative 4 plus 10. That's going to be positive 6. Okay, and so that's it. That's my answer. Incidentally, sometimes I'm asked the question, is it okay if you leave it like this? Yes, of course. It doesn't literally have to be x term followed by y term on the left hand side. As long as both x and y terms on the left hand side, that's fine. So 2y subtract x equals 6 would also be fine. Okay, I'm hoping that you understood that. Okay, hoping that was helpful too. Okay, the next example is very similar to the previous one. The only thing I've changed, notably, is this word here. We need to find an equation of a line that's perpendicular to this equation, passing through this point, and we need to leave it in that form there. X by c equals 0. Okay. Sometimes it's helpful when you're doing a question in an exam to highlight the key bits, okay? Make sure you know it's perpendicular, otherwise you get the gradient wrong. Make sure you leave your final answer in the correct form as well, okay? So the first thing we'll do is write down what the gradient is, and we can do that. The gradient is -3/2. You need to be able to write that down as quickly as I've just done. Here's a quick explanation coming up. So here you've got a gradient of 2/3, okay? So I'm going to write m1 is equal to 2/3. So that is, for example, a sketch of what this line might look like, where it's 2/3 x minus 11. And we're after a line that's perpendicular to it, okay? That's perpendicular. And so the gradient has got to be -3/2, because you remember the result that I put in the previous video, okay? That is when the two lines are perpendicular, the product of their gradients is -1, okay? And the quick way of looking at it is, you've got the gradient of one of them, take the reciprocal, multiply by -1, okay? Reciprocal of that is 3/2, and multiply by -1, -3/2. So that's why you should just be able to look at the equation there and write it down. Now this has been put in a nice form for us because I wrote it in the form y equals mx plus c. If it's not in the form y equals mx plus c, you have to just rearrange it and find the gradient like I did in the previous video, okay? So we've got that bit started off nicely, and then all we do is just use the equation y minus y1 equals mx minus x1 and substitute in the values we know. So y coordinate is -4, so that's y subtract -4, so y plus 4 that will be. M is -3/2, and then x subtract, and the x coordinate is 7. Okay, so that's our equation of the line that's perpendicular to this one. Now we just need to put it into this form. So as with the previous example, when there's a fraction there, don't expand the brackets, just multiply both sides by the denominator, so that's 2. So multiply both sides by 2, we're going to get 2y plus 8 is equal to -3x minus 7. Now we've got integers, you see, and we want our a, b and c to be in integers. I'm going to expand the brackets next. 2y plus 8 is equal to -3x plus 21, and then just check again. Right, everything has to be on the left hand side and 0 on the right hand side. So put that over there. So 3x plus 2y. I'll put this over there as well. 8 subtract 21. That's going to be -13 equals 0. That's it. Okay, that's done. Okay, let's look at the next example. The lines y equals 4x minus 7 and 2x plus 3y equals 21 intersect at point A. Okay, so the first thing we're going to have to do, of course, is work out that point of intersection. Point B is at -2, 8. Find the equation of the line that passes through A and B. Find the distance AB as well. Okay, so going back to this, we have to find the point of intersection. So that's what we're going to do with a question like this. Just break it up into little bits to make it more manageable. Okay, so it's always the case with a maths question, you're trying to find out what to do first, how to get the ball rolling. So this is the first step. Solving these, we're going to have to solve them simultaneously, because that's what points of intersection are all about, simultaneous equations. And the simplest way is if we substitute that into there, okay? So let's do that. So 2x plus 3y, so 3 times 4x minus 7 is equal to 21. Hopefully you can see how that works. And then we just work out what the value of x is. So 2x plus, that's going to be 12x, subtract 21 equals 21. So simplifying that, 14x is equal to 42 and x is equal to 3. Okay? And because it's a point of intersection, we need to find the y coordinate as well and use that equation to do it. So 4 times 3 is 12, subtract 7 is 5. Okay, so y equals 5. Of course, we should just check that it works with the other equation as well. So substitute these in. So 6 plus 15, that's 21. Great, that works. So what that means is point A has got coordinates 3, 5. Okay, and then we go on to the next part of the question. Now, if you don't mind, I'm just going to rub this working off. Hopefully you've got it already. If not, obviously you just rewind it and do a screenshot, okay, or pause it. This is a wonderful thing about videos, you can do that, okay. Of course, in class, once I've rubbed it off, it's like, yeah, a bit difficult to put it back on. So I'm just going to put in here, point A is 3, 5. I'm also going to put the other point B, which is negative 2, 8, because those are the two crucial points in this question, aren't they? What we've got to do, find the equation of the line that passes through A and B. So go back to one of the very first examples, okay? Find the equation of the line that passes these 2 points. Okay, it's quite simple. We need to find the gradient, don't we? So I'm going to put this here. M is equal to, because of the negative, I'm going to do it this way around. 5 subtract 8 and 3 subtract negative 2. So difference in the y coordinates. So 5 subtract 8 on the top there, and on the bottom 3 subtract negative 2. That's the same as 3 plus 2, isn't it? Okay. So 5 subtract 8, that's negative 3. And on the bottom is going to be 5. So negative 3/5. That's the gradient, okay, of the line. So I'm going to write down, therefore, y minus, do you want to write down the equation again? You've seen it so many times. I'll just say it, y minus y1 equals mx minus x1. And we've got a choice of which coordinates to use here. I'm going to use that one there, okay. So y minus 5, okay, is equal to the gradient, m negative 3/5, and then x minus x1, that's going to be x minus 3. Okay, there we go. I'm sure you're happy with that. The question doesn't say leave it in a particular form, but it's probably best we do something with it, okay, to simplify it a little bit. So what I'm going to do is I'm going to first of all multiply everything by 5 to get rid of the fraction. So on the right hand side, sorry, left hand side, that would be 5y minus 25, and that would be negative 3, x minus 3. Then I expand the brackets here, so 5y minus 25 is equal to negative 3x plus 9, and then I'll just put the x term to this side. So that'll be 3x plus 5y, and why don't I just subtract 9 as well? Subtract 34 equals 0. Okay, it's usually a good idea to be in the habit of writing in this form, because that's often how an exam wants it left. ax plus by plus c equals 0, where a, b, c are integers. Okay, so that's that bit done. Part 2, find the distance AB. Okay, so the distance between points A and B. Okay, do you remember how to do this? It's Pythagoras' theorem, isn't it? And even though I don't require a lot of space, a lot of working to do that, I'm just going to rub all of this off. Okay, and again, if you didn't quite get all of that, just rewind and do it up again. It won't take long to do that, will it? So we're after the distance between these 2 points. Do you remember the distance formula? Okay, well, if you didn't, just think of it this way. So here's a generic straight line, here's 2 points, okay? Just work out the distance between the x coordinates and the y coordinates, okay? So you're looking at, what's the difference between 5 and 8? It's obviously 3. What's the difference between 3 and negative 2? It's obviously 5, okay? But if you were to substitute them into the formula, like the formula I showed you, you would have it written like this, okay? The difference in x coordinates is 3 subtract negative 2. So it's 3 plus 2, we'd have to square that, and difference in y coordinates is going to be 8 subtract 5, and then square them together, and then to find the distance you'd square root all of that. Okay, so it's going to be 5 squared plus 3 squared, and the square root of that, so it's 25 plus 9 square root of 34. So your distance is root 34. Okay, I'll just think about whether you could simplify it as a third, and no, there's no square number that goes into root 34, so that would be your answer. Okay, I'm hoping you found that useful, and there's another example coming right up. Okay, let's have a look at this last example then. Right, the straight line L1 has equation y equals 7x minus 3. The straight line L2 has equation 4x plus 3y minus 41 equals 0. The lines intersect at point A. L2 crosses the x-axis at point B. Find the area of triangle AOB where the origin is marked as 0. Okay. So what I've done is I've just saved myself a bit of space by doing shorthand notation. So little triangle AOB means triangle AOB. I'm sure you figured that out. And O is always used to represent the origin. Why don't you pause the video and have a go at it yourself, see if you can do it. Then unpause it and see if you're alright. Or alternatively, of course, you can just keep on going and work through it with me. So, breaking it down step by step, the first thing I think we need to do is find where the lines intersect, don't we? We need to find where the lines intersect point A. So, we'll do that by solving these simultaneously. So let's just do that. So 4x plus 3y where y is 7x minus 3. Subtract 41 is equal to 0. And then we'll have 4x plus 21x minus 9 minus 41 equals 0. So that's going to be 25x subtract 50 equals 0. So 25x equals 50, x equals 2. Always nice when it turns out to be integers, doesn't it? Okay, so x equals 2, and we need a coordinate point of intersection, so the y coordinate would be, let's use that one. So 7 times 2 is 14, subtract 3 is 11. And we better just check it works in there before moving on. So that's going to be 8 plus 33, which is 41, and yeah, subtract 41 equals 0, so that works. Okay. So what I'm going to do is I'm going to write that coordinate point in. So intersection point A, that's 2, 11, like that. Okay, because I need some more space now. I'm going to clean that off and set to work on the next bit. Okay, so point B, we need to find where that is. Okay, now this sort of thing comes up quite a lot. The line crosses the x-axis at point B. What to do in that scenario? Okay, so any coordinate grid, okay, with any line crossing the x-axis, notice that the y-coordinate is 0. Okay, so what you're going to do is you're going to use y equals 0 in the equation. Just as if it crossed the y-axis, you'd use x equals 0 to find that. That's of course called the y-intercept. Incidentally, this is often called the x-intercept. Okay, so we're going to use y equals 0 with that equation there. So we've got 4x plus 3y, which of course is 0, subtract 41 equals 0. And so work out x's, 4x equals 41. What was I saying about it's nice when you get integers? Well, this one's not an integer, is it? Okay, but it's quite simple to write down the answer. It's 41 over 4, and I would leave it like that if I were you. If it pleases you, write it as 10 1/4, 10.25, but I'm going to write it as 41 over 4. Okay, so that's point B. So right here, point B is 41 over 4, and of course the y-coordinate is 0, isn't it? Okay, so that's that. And then we move on to the next part of the question, which is this: find the area of triangle AOB. I strongly recommend to you that you draw a sketch of the shape here. In any coordinate geometry question, or any question really, where you've got to find the area of a shape, draw the shape out. Okay, try not to do it all in your head, because one simple mistake is going to ruin everything. Okay, so just draw a quick sketch and see what's going on. Okay, so that's easily done. Look at this. So x-axis, y-axis. One of the points is the origin, so there, of course, 0, 0. One of the points is 2, 11, so roughly there, say, that's 2, 11. And the other point is there, 41 over 4, 0, so there, okay. So let's just label that in, 41 over 4, 0, okay. But then just join them up to make a triangle, okay, like that. And that's your triangle OAB, all right? And the question is to find out the area of that triangle. The formula to use for area of triangle questions is just simply half base times height, okay? Half base times height, where this bit here is your base and this here is your height, okay? That's it, that's all we need. So what is the base of it going to be? It's going to be difference in x coordinates, so 41 over 4. And what's the height of it going to be? It's labelled by that y coordinate there, which is 11. Okay, simple as that. So we're going to do a half times base, 41 over 4, times by the height, which is 11. Okay, that's all we have to do. And we can do that without a calculator, I think. So on the numerator, 1 times 41 times 11. Yes, you can do 41 times 11. So 41 times 10 is 410. Of course, and then add on another 41, okay, you'll get 451, okay, you can probably do that in your head, I'm hoping you can do that in your head, okay, so 451, and on the denominator, just 2 times 4, okay, write the over 1 there if it pleases you, that gives you 8, and I'm not seeing that that's going to simplify nicely, so 451 over 8, okay, and finishing off, just write down square units. if you want. Okay, there's no units attached to the question. In fact, in A-level maths, if you just write 451 over 8, you'll be fine and you'll get the mark for the final answer, because no units are generally given for this type of question. Okay, and that is it. Okay, that's it. I'm hoping you found these examples useful for you. I'm hoping you found them helpful. The thing to do, of course, to understand all of this is to do as many questions as you possibly can. So it's time to open up the textbook and just work your way through as many questions as you possibly can through the chapter. Okay? Hope you enjoy doing that and have a good day. Bye bye.